Welcome to MrCScience.com's video on the ideal gas law. We've learned a bit about gases now. One thing that's would be good about to use with gases is to somehow easily relate moles to the gas. Now we talked about that earlier, but in reality it's hard to take the mass of a gas. There's lots of things. Some gases are lighter than air. You'd have to take the mass inside of a vacuum or something. So instead, they have the ideal gas law, which allows us to do that. So ideal gas law is listed as PV equals nRT, PVnRT. P stands for pressure. V stands for volume. N stands for moles. Why N, you say? Well, lowercase m stands for mass, and so that's why we don't use that. R is our ideal gas constant. And T is our temp in degrees Kelvin. So all of those. So we can measure pressure relatively easy, the volume of a gas, the temperature, and if we have the ideal gas constant from that, we can derive moles. One thing you'll need to know is what is the ideal gas constant? Well, the one we're using in our book is R equals 0.0821, I believe. Let me look quick. Yep. 0.0821 liters atmosphere per moles Kelvin. Liters atmosphere per mole Kelvin. So you're going to need to know this. This ideal gas constant works for all gases, but sometimes you'll see a different ideal gas constant in outside of this book. If they use a different volume, milliliters, cubic meters, any form of volume, we'll change that. Same with, we saw that there are 4 different ways that we scientists currently measure atmosphere in. Pascals, millimeters mercury, torrs, or atmospheres. So the one we're using uses liters and atmospheres, and moles and Kelvin are the same across the board. Let's go ahead and use that once to generate moles. So just take an example in your book. They say a gas in a 12.2 liter container. So that means that our volume equals 12.2 liters. At a pressure of 1.05 atmospheres. So P equals 1.05 atmospheres. And a temperature of 25 degrees C. Temperature equals 25 degrees Celsius. How many moles? So our number of moles, N equals question mark. So first thing we have to do is, as always, look at your units. Liters are right, atmosphere right, Celsius is wrong. We need Kelvin. So how we convert Celsius to Kelvin is we just add 273. Those of you that are saying 273.15, that's true, but I'm not going to worry about the 0.15 at this point. So what does that make? 298, 298 K degrees Kelvin. Okay, so we got everything we need. We're looking for moles. Let's just rearrange the equation so moles is on one side. So to get moles all by itself, we just have to divide both sides by RT. So that's going to give us an equation, N equals PV over RT. So then let's just plug in what we know. Pressure is 1.05 atmospheres. And volume is 12.2 liters over. Our R is 0.0821 liter atmospheres per mole Kelvin times our temp of 298 degrees K. do all the funky math there, and you get 0.524. And what are your units? Well, atmospheres cancel, liters cancel. K cancels because you got K here and you got 1 over K here. So you're left with 1 over moles. So 1 over 1 over moles, which you flip it around is moles. So our gas has molar value of 0.524. From that, we can generate its mass by knowing how much 1 mole of the gas or of the molecule is its mass. So pretty short video, but hopefully that got the point across. Remember, know your PVNERT, ideal gas law, PV equals nRT, and know your ideal gas with liters in atmosphere of 0.0821. If you have any questions, feel free to contact me at mrc@mrcscience.com. Thank you.